The ninth question that we have is a very important problem. We have to prove that the equation of the two planes inclined at an angle alpha to the xy plane and containing the line represented by these two equations is x square plus y square tan square beta plus z square minus 2xz tan beta is equal to y square tan square alpha. So for finding out that, let us first see these two equations. Both of these are equations of plane in 3 dimensions. Now the line represented by them is the line of intersection of these two planes, and any plane passing through the line of intersection of these two planes is given by p plus lambda q is equal to 0. This is the plane passing through the line of intersection of these two planes. Therefore we can write this as x sin beta minus z cos beta plus lambda times y is equal to 0. Now the plane represented by xy plane is z is equal to 0. Now these two planes are making an angle of alpha with each other. Therefore the normals will make an angle of alpha with each other. Whenever there is a talk of the angle between the planes, you should always think about the angle between the normals, which is same. Now the normal of this plane is represented by sin beta I cap plus lambda j cap minus cos beta k cap, and for this one it is just k cap. Now to find out the angle between these two vectors, we take the dot product, that is minus of cos beta. This will be equal to modulus A into modulus B into cos theta, that is the angle between the two planes, that is cos theta into modulus A into modulus B. Modulus B is already 1 and modulus A will be equal to root over sin square beta plus cos square beta, that is 1 plus lambda square. So now we get cos theta is equal to minus of cos beta upon root over 1 plus lambda square. We need to find out the values of lambda to get the value, to get the plane we require. Now from here we get root over, or rather 1 plus lambda square to be equal to cos square beta upon cos square theta. So on solving this we get lambda is equal to root over cos square beta minus cos square theta upon cos square theta, and we'll add plus minus over here because we have taken root over on both sides. So we get two values of lambda. So for two values of lambda we'll get two planes, and these are the two planes that we want, and the combined equation of the two planes we need to prove that is equal to this. Now let us write the combined equation of the two planes when we know that lambda is equal to plus minus root over cos square beta minus cos square theta upon cos square theta. The equation of the first plane will be x sin beta minus z cos beta plus lambda y is equal to 0 and minus lambda y is equal to 0. Therefore the combined equation will be x sin beta minus z cos beta plus lambda y into x sin beta minus z cos beta minus lambda y is equal to 0. This can be written as x sin beta minus z cos beta whole square minus lambda square y square is equal to 0. The value of lambda square can be written as cos square beta minus cos square theta upon cos square theta. This is equal to 0. Now we have already got an expression in terms of x, z, cos beta and cos theta. We just need to prove that this equation is the same as this equation. So for that let us expand this. X square sin square beta plus z square cos square beta minus 2xz sin beta cos beta plus y square is equal to y square cos square beta into sec square theta. Now on dividing the whole equation by cos square beta we get tan square beta over here, we get z square over here, and we get tan beta over here, and sec square beta over here plus y square into sec square beta. This will be equal to y square into cos into sec square theta. Now we are seeing a term of x square plus y square tan square beta over here. So to get y square tan square beta, let us write this sec square beta as 1 plus tan square beta. So this will be y square plus y square tan square beta. Therefore we can write y square plus x square into tan square beta over here. Therefore we get this term already, and we also get z square, and we get minus 2xz tan beta is equal to y square tan square alpha. Therefore y square sec square theta minus 1 can be written as y square tan square theta. Now theta was the angle between the planes xy plane and the plane. Therefore this theta is equal to alpha, and thus we get our required equation to be proved, and thus this is how we have proved the final answer.